Hello, this is Derdeen Mohammed. In this video, we are gonna talk about NumPy. First, what is NumPy? NumPy stands for Numerical Python, which provides Python with extensive math library. Okay, why to use NumPy? First, speed, as we will see in the next examples, and second, multi-dimensional array data structure, we will see in the following examples, and three, optimized built-in mathematical functions. First of all, we will see an example where we will use plain Python to calculate mean of a large number, and we will use NumPy to calculate the same mean, and we will calculate the time used by Python and by NumPy to get the result. So first of all, we will import time. We will import time for this example only, and import NumPy as NP. Uh, as we said before, this means that the cell run. Second, we will make an x equal np random dot random 10 million. We are calculating a very huge number. It will take a while because it's a very large number. In case 1, without NumPy, we will start equal time dot time. We will calculate the start time of the code, and then we will calculate some x over len x, and print time dot time minus start. We will see the time taken by Python to calculate some x over len x, mean of x. As you see, it's taking a while because plain Python without NumPy in large numbers takes a while. Here it took 19 seconds, which is large, which is a large number, because if you are dealing with many numbers and much more large numbers, this will not make your work go easy. Okay, in case 2, we will do the same, but instead of sum x over len x, np dot mean x, a very built-in function in NumPy, very straightforward. And did you see the difference? The difference here, it took 19 seconds without NumPy. Here it took 0.23 or 24, if we make it to the nearest number, 0.24 of the second, less than 1 second. So this is why we are using NumPy. Okay, at the core of the NumPy is the ND array. ND array, it is a multidimensional container of items of the same type and size. Why it's important? Because the ND array, it's the core of NumPy, and it can hold integers or strings. It's important because in many machine learning problems, you will find yourself often using the ND array in many different ways. For example, if you might use ND array to hold a pixel value of an image that will be fed to a neural network for image classification. This is for example. Here, we are not going deep into this, but I'm only explaining why it's important. Here we will create a 1D array. There are different arrays. So here I'm creating a 1D array, x equal np dot array, from 1 to 5, and I want to print x equal and the array. And here x equal, and it gave me the array 1, 2, 3, 4, 5. We will see in next examples the difference. The rank of the array. I want to know, I have an array. If you are working and you have already an array, and you want to know the rank of the array. The rank of the array means, is it 1D, 2D, 3D, and so on. So rank of an array, the syntax of it is n the array x here, for example, and n dot n dim. Okay, here x equal np array of this, and I want to know the rank 1 because it's a 1D array. Okay, if I'm dealing with an 2D array, this is a 2D array. You see the difference? Here it's only one set. Here there are four sets, and it gave me 2 because it's a 2D array. Okay, we are going to know some useful functions to know the types of your array, the different information about the array you are working with. Example 1, using a 1D array for integers. I'm having an np.array integers. I created this array, and then I want to print x equal and the array, and then I want the dimensions. The dimensions is by x.shape. To know the dimensions, the dimensions here will the dimensions mean you want to know how many columns and how many rows. The array are in columns and rows, but in the name of array. And then I want to know the object type, the type of x, it's an array, and the type of elements in x. Here they are integers, like we will see here, x equal and the array. X has dimension of 5 because we have 5 columns. X is an object of type class in the array, numpy.nd array, and the element in x are of type integer 32. This means that they are integers, and they are the space they are taking is 32 bytes. Okay, example 2, using a 1D array of strings. Uh, I'm going to create an array of np.array hello and world, and I want to know the shape, the type, and everything here. X equal hello world, and x has dimension of 2 because I only has 2 columns, and the object type is nd array, but here the element in x are of type u5. What is meant by u5? U5, it is an unique, u means a unicode of strings, unicode string, and 5 is the number of characters in the string. So u5 means that each element in the array is a unicode string of length 5. Okay. Example 3, using a 1D array of mixed data. Here I'm using a mixed data, and I will see what it will. Here I got the array, and the dimension is 3 because they are 3 columns, and class in the array, and the type is U11 because they are mixed data. And then example 4, I will do an 1D array of integers and floats. Here I will create a 1D array contains integers, and here contains floats, and here contains integers and float, and I will only get the D type to know what it will tell me. Okay. Here, as you see, the integers, it got me integer 32 because they are in 32 byte, but the floats are 64 because they are in space of 64 bytes, and z, it's a float. As you see, the array containing integers and floats, it results in a type of element float, not integers, because there is a float. Here I'm using a 2D array. You will see the dimensions that will result. So I will create an array of y equal np.array, and here are, and print y equal and y slash n. This will result the next to it to be in the next line. It's like I'm doing enter to start from the next line, and I will know the shape, the size, the type, and okay. And as you see, y equal, this is what n did, and here I have three columns and one, two, three, four rows. So the dimensions are 4 and 3, 4 rows and 3 columns. Y has a total of 12 elements. Here I'm having a 12 elements. If we count them, they are 12 elements. So this is done by Y size. I want to know, if I want to know the size of the array, by size. And then it's a numpy in the array of integers. Okay, I created a 1D array and a 2D array, and I did know all the information about them, how to save a numpy array. Here, x equal, I will create an x equal np.array and save by np.save, and the name you want, and x, the array you are dealing with. So np.save my array and enter. We in few seconds I will tell you how to load the array, but I want you to see that it's saved, despite of there is no output. So I will go to file, file, open, and here this is my workspace. This is my directory. Here I saved it in the current directory I'm in. So here, and as you see, here is the my array.npy as I saved. npy because it's a numpy. Okay, here how to load my array, how to load it. So I will y equal np dot load my array dot npy. You must do dot npy because or it else it will give you an error. In Python, you must call the saved file by its extension also. So I will load it in y. Here I saved it as X array. I will load my data in Y. So I will print Y and print the objects and type and all of that. And enter. As you see, it printed the X array I saved, but in a Y variable, and class and integers and so on. Okay, here we are going to, now we are going to use several functions built in NumPy array. NumPy, sorry. Example one, we are going to create a NumPy array of zeros. What is np.zeros or nd array of zeros? It's an nd array with a specified shape full of zeros, and this is done by np.zeros. Here I'm specifying the shape 3 and 4, 3 columns, 4 rows, and so on. Um, for example, if you want to create a rank 2 array with 3 rows and 4 columns, here I'm specifying what I want. Okay, and as you see, 4 columns, 3 rows of zeros. ND arrays are used in many things. As I told you, in images or in AI programs and so on. Okay, the dimensions are 3 and 4, as I said before, and it's a float because here 0 dot 0. It's a float, not an integer, and it's an array. Okay, create a NumPy array of ones. NumPy array of ones, it will make an arrays of ones, zeros, and one in the diagonal, as we will see. Sorry, it will make an array of ones. Here, I created three rows and two columns, and the dimension are 3 and 2, and it's in the array and it's float. Okay, I want to make a full create a NumPy array of constants. For example, I'm using 5. It will make an NP array. I will show you it's better. Here, I want to make a 2, as you see, a 2 rows and 3 columns of any number I want. Here, I asked for 5. So it resulted in a 2 rows and 3 columns of 5. And the dimensions, and it's in the array, and it's an integer because I asked only for 5. I entered the integer I want, which is 5. Okay, how to create an NumPy array of identity matrix. What is the identity matrix? It's a square matrix in which all the elements of the main diagonal are equal to 1 and all other elements are equal to 0. Here I asked for an x of x equal np dot I 5. I want 5 ones inside zeros. And as you see, 5 ones in the diagonal and all the other is 0. So here the dimensions are 5 and 5, 5 rows and 5 columns, because I want the 5 ones in the diagonal, and it's a float because I didn't specify the number. Here, example 5, I want to create a NumPy array of constants. Here I want to create a 4 multiply 4 diagonal matrix that contains number on its main diagonal. Here I want to specify the numbers in the diagonals. Here I didn't specify it. I only said 5 numbers in the diagonal, so the NumPy added ones. But here I'm specifying the numbers I want in the diagonals. Here I specified 10, 20, 30, 50, and also we are going to know all the information. As you see, there are 4 rows and 4 columns, and the numbers I added are in the diagonals 10, 20, 30, 50, as you see. And it's a number array and it's an integer because I specified the numbers of integers. Example 6. Create a NumPy array of evenly spaced values in a given range using a range stop value. Here, the range uses a start and stop and step. Okay, here I will specify only the stop value. I will create a 1D array that has sequential integers from 0 to 9 with a very simple. Here you are seeing that the functions built in NumPy are very easy to use. Okay, np.arrange 10. If I added only one number, the it will take this number as the stop value, not the start, not the step, the stop. Okay, and as you see, a sequential array, an array of sequential numbers from 0 to 9. Here, the stop value is exclusive, which means 10 is not inclusive in the array. And the dimension are 10 because there is only the 10 numbers, and class is in the array integers 23. Okay, here I want to make an array of a range start value and stop value. Create a rank 1. The array has sequential integers from 4 to 9. Here I specify two numbers. These are the start and this is the stop with also it's an exclusive. It will not be used in it. And as you see, 4, 5, 6, 7, 8, 9, and the dimensions, x has a dimension of 6 and array and x is the type of integers 32. Example 8, and it's the last example in this video. Create a NumPy array using a range, start, stop, and step. I will create a 1D array that has evenly spaced integers from 1 to 13 in steps of 3. So start is 1, stop is 14, so 13 will be used because 14 is exclusive and 3 as a steps. Here you will see there are different numbers, but the space between them is 3. 1, 4, 7, 10, 13, and the dimension is 5, and the object type is array and in the array, and the type of elements are integer 32. Today we talked about what is NumPy, what is important, and we calculated the time used by Python and NumPy to calculate a mean of a large number, and we learned how to build a 1D array and a 2D array and how to get all the informations of it and how to build arrays of zeros, ones, and diagonal. And see you in the next video.